Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor from Aero Education Network, and today I'm going to solve some questions from International A-Level Edexcel M1 Mechanics Past Paper Handout. Topic is Vectors in Mechanics, chapter number 3. And first of all, we have the question number 1 of the handout, which is January 2010, question number 7. So the information given to you in the question is that a ship S is moving along a straight line with constant velocity. At time t hours, the position vector of S is s kilometer. When t is equal to 0, S is equals to 9I minus 6j, meaning this is the initial position vector of the ship. Initially, when time t is equal to 0, the ship is over here at this point. So this is basically the r naught vector. Okay, the initial position vector of the ship. And when t is equals to 4, when t is equals to 4, the position vector of the ship is 21I plus 10j. We need to find the speed of the ship. We need to find the speed of the ship S. Okay, so this essentially means first we need to find the constant velocity vector over here. And once we are able to find the constant velocity vector, we would be able to find the magnitude of that velocity vector and we would be able to tell the speed of the ship. So as we know the fact that the basic vector equation is r is equals to r naught plus v times t. So r vector is given to you when t is equals to 4. Basically, the position vector of the ship is given to you, okay, at a particular value of t which is greater than 0. So this is basically the r vector over here. Okay, so I'm going to say that 21I plus 10j is equals to the r naught vector is also given to you in the question, and then plus v times 4. The value of t is 4 and the velocity vector is unknown. Okay, so therefore I'm going to say that 4v is equals to 21I minus 9I plus 10j plus 6j. Okay, so 4v will be equals to 12I plus 16j, meaning v is equals to the I component will be 12 over 4. Okay, and the j component will be 16 over 4. So this means that the constant velocity vector is 3I plus 4j kilometer per hour, since the information given to you in the question is that t is basically hours, the time is given to you in hours, and the position vector is given to you in kilometers. So this velocity vector is 3I plus 4j kilometer per hour. So now we need to find the speed. So speed is basically the magnitude. Speed is basically the magnitude of the velocity vector. So the magnitude of this vector will be under root of 3 square plus 4 square, meaning under root of 25. So therefore we are going to say that the speed is 5 kilometer per hour. This is supposed to be our answer. The speed of the ship, the speed of S. Okay, so here was a requirement for part A, which was worth 4 marks. All right, so now let's move on to part B. It says that we need to find the direction in which the ship is moving and we need to give our answer as a bearing. Okay, so basically the velocity vector tells you the path of the motion of the particle, the path of the motion of the object, meaning when we have this velocity vector, which is given to you 3I plus 4j kilometer per hour. So this means that, that ship S is moving in this path horizontally 3 units and vertically 4 units above, meaning horizontally 3 units towards the right and vertically 4 units up. All right, so this is basically the path of motion. We can say that this is the direction of motion of the ship, the velocity vector. Okay, so what we need to do, we need to find the bearing over here. All right, so at the starting point of this vector, we are going to make a north. And this essentially means that we need to find this angle theta over here. Agreed with this? Because we need to find the bearing. We need to tell the bearing. So what we can do, first of all, we can find this angle X, let's say this angle with the horizontal. So I can say that this angle X will be We can find this by opposite over adjacent. So we are going to uh, use the ratio of tan theta, which is equals to opposite over adjacent. Specifically, this angle with the horizontal is x. So I can say that tan x is equals to 4 over 3. So this angle x will be equals to tan inverse 4 over 3. However, we need to find this angle theta. So in order to find this angle theta, I can say that 90 minus tan inverse 4 over 3. As simple as that. So 90 minus tan inverse 4 over 3. This is supposed to be 36.87 degrees. Theta is equals to 36.87 degrees, but we need to tell our answer as a bearing. So therefore, I'm going to say that, therefore, the bearing is, we have to write our answer as a three-figure number. So therefore, the bearing is 037 degrees, correct to the nearest degree. Okay, so this is supposed to be our final answer. The bearing is 37 degrees. So, I mean, the angle is 37 degrees. So bearing is 037 degrees as a three-figure number. Alternatively, what you can do over here is that, you know, since you need to find this angle theta, so this opposite side over here would be 3 and the adjacent will be 4 over here. Okay, so you can simply find this angle theta by using this thing that tan theta is equals to opposite over adjacent, meaning 3 over 4. So theta will be equals to tan inverse 3 over 4, which will give you the same angle over here. All right. So alternatively, you can do it in this way as well. So I'll just make a separator over here. This complete working was for part B. And this was basically an alternative approach over here. Okay. So now let's move on to part C. So the requirement of part C is to show that S vector in the form of I and j is this, where t is unknown. The I component is 3t plus 9 and the j component is 4t minus 6. We need to show this thing over here. All right. So I'm going to bring the question. I'm going to bring the picture of the question on the next page so we can do working over here. Okay, so as we know that, the r naught vector was given to us in the question and the constant velocity vector which we have already found. And since in this particular question the velocity is constant, so we can say that r is equals to r naught plus vt. Otherwise, the concept is like this, that r is equals to r naught plus s, where s is basically the displacement vector. Okay, this is basically the very basic equation. But in the questions where the velocity is constant, so displacement is basically v times t, isn't it? Since velocity is equals to s divided by t, where s is basically the displacement. So in place of s, we can write vt. So since the velocity is constant, we are going to use this particular equation over here, r is equals to r naught plus vt, which I have also used for part A. Okay, so the constant velocity vector we have found 3i plus 4j kilometer per hour. Okay, so r is equals to what? The initial position vector is given to you over here in the form of I and j. Okay, and the v vector which we have already found in part A, which is 3i plus 4j, and the value of t will be kept unknown because we need to find the vector, we need to find the vector of the ship in terms of I and j and in terms of t as well, because t is unknown right now. So we just need to expand this and simplify and we would be able to show. So r is equals to what? We are going to expand this. So 3ti plus 4tj. So I'm going to say that taking I as common, we'll be left with 9 plus 3t. This is basically the I component. Okay, and as far as the j component is concerned, so taking j as common multiplied by 4t minus 6. This is basically the j component. So now I'm going to write my answer in the required form, that the I component is 3t plus 9. Okay, and the j component is 4t minus 6. This is supposed to be our answer. So now let's move on to part D. Uh, Before part D, we have some information that a lighthouse L is located at the point with position vector 18I plus 6j kilometer. When t is equals to capital T, the ship S is 10 kilometer from L. The requirement of part D is to find the possible values of t. So first of all, in order to solve this part D, we are going to, make a sketch over here. I'm going to make a sketch over here for your ease. Okay. So let's say we have the x's over here. All right. So the position vector of the object L, meaning the lighthouse, this is 18I plus 6j kilometer. So from the origin horizontally 18 units and vertically 6 units. So let's say somewhere over here. Okay, this is, let's say this point is 18 comma 6, meaning the vector is 18I plus 6j. And when t is equals to capital T, the ship S, the distance of ship S is given to you from the lighthouse. Okay, so as we know that the ship is going in this way, that initially the ship S was at this point. Okay, which you can say the I component is 9 and J component is minus 6. Okay, so let's say X coordinate is 9 and Y coordinate is minus 6. Let's say somewhere over here. This is the R naught, the initial position vector of the ship S. Ship was initially over here. Okay, and then the ship is going in which particular path? 3I plus 4j. As we know, the constant velocity vector is 3I plus 4j kilometer, meaning horizontally 3 units towards right and vertically 4 unit above. Okay, so ship is traveling in this particular path. So I'm going to make a line over here, sloping line in the path of, the motion of the ship. Okay, the ship is traveling in this particular path. So as we are interested in the distance of the ship from the lighthouse, so we would be concerned with the displacement vector of LS, meaning from L till point S. So I'm making a broken line over here. Okay, so obviously I need to be concerned with the LS vector. So first of all, I'm going to find the LS vector. Okay, so this means according to the vector subtraction law, this is OS minus OL. So the position vector of the ship at any point where t is unknown, this we have achieved in, part C. Okay, so I'm going to use this over here. The I component is 3t plus 9 and the j component is 4t minus 6. I'm doing the working in the form of column vectors. Okay, and from this I'm going to subtract the position vector of the lighthouse, which is 18, 6. So this means that when we simplify this vector, so I component will turn out to be 3t minus 9 and j component is 4t minus 12. This is basically the LS vector, the displacement vector LS. Okay, so now as per the information given to you in the question is that when t is equals to capital T, the distance between the lighthouse and the ship is given to you. Okay, so we are going to say that the magnitude of this LS vector is equal to 10 kilometer. Okay, so we are going to write our vector like this, that in place of t, we are going to have capital T. So I component is 3t minus 9 and j component is 4t minus 12. So the magnitude of this vector would be under root of 3t minus 9 whole square plus 4t minus 12 whole square, and this will be equal to 10 kilometer. Okay, so now we have to take whole square on both sides. Okay, so this means that 3t minus 9 whole square plus 4t minus 12 whole square is equals to 100. We need to expand and simplify the equation and then solve the equation over here. So I'm going to do the working over here. So a minus b whole squared, meaning 3t is squared first. Okay. So a square minus 2ab, meaning 2 times 3t times 9. So minus 54t, and then plus 81, and then plus 4t whole square. So 16t square, 16t square, and then, you know, 2 times 4 times 12. So after 16t square, we have minus 96t, and then plus 144 minus 100, and this will be equal to 0. Okay, so we need to simplify the terms. So 9 plus 16, this is 25, so 25t square, and then minus 54 minus 96, this is minus 150, so minus 150t, and 81 plus 144 minus 100, this is supposed to be 125. So plus 125, and this whole thing is equals to 0. So if we take 25 as common, we are left with t square minus 6t plus 5 is equal to 0. Therefore, we need to solve this quadratic equation. T square minus 6t plus 5 is equal to 0. So t square minus t minus 5t plus 5 is equal to 0. Taking t as common, multiply by t minus 1, taking minus 5 as common, multiply by t minus 1, and this whole thing is equal to 0. Therefore, fully factorized form is t minus 1 multiplied by t minus 5 is equal to 0. Therefore, the possible values of t are t is equals to 1 and t is equals to 5. This is supposed to be your answer. Okay, so this means that when t is equals to 1, when the time is 1 hour, okay, so the ship is, let's say, somewhere over here at t is equals to 1, and the distance between the lighthouse and the ship is as given to you in the question. Okay, when t is equals to 1, and in the same way when t is equals to 5. Okay, in this way we have attempted this question. So t is equals to 1 and t is equals to 5 are your answers to part D. All right, so this was basically handout question number 1, which is January 2010, question number 7. All right, so now let's move on to question number 2 of the handout. And this question is June 2010, question number 1. The question is saying that a particle P is moving with constant velocity minus 3I plus 2j meter per second at time t is equals to 6 seconds. The particle P as, at the point with the position vector minus 4I minus 7j meter. We need to find the distance of the particle from the origin at time t is equals to 2 seconds. Okay, so first thing first, uh, what we have to do, we have to make the vector equation over here. R is equals to R naught plus Vt. Okay, we know the constant velocity vector, and we know the position vector of the particle when t is equals to 6, meaning we know the R vector, which is minus 4I minus 7j. Okay, and this will be equals to R naught plus Vt. R naught is unknown to us. R naught is not given to us in the question. So first of all, we have to find the R naught, and the constant velocity vector is given to us, which is minus 3I plus 2j, and the value of t is basically 6, meaning the R vector is minus 4I minus 7j when time t is equals to 6 seconds. Okay, so I can say that minus 4I minus 7j is equals to R naught, and then plus this is minus 18I plus 12j. So therefore, I'm going to say that the R naught vector is basically minus 4I plus 18I minus 7j minus 12j. Okay, so far we have achieved this thing. So R naught vector is basically 18 minus 4 is 14. So 14I minus 19j. This is the R naught vector. And now we have to use this vector in order to find the distance of the particle from the origin when t is equals to 2 seconds. So again, we are going to use the equation R is equals to R naught plus Vt. And now since we know the r naught vector, the initial position vector of the particle, which is 14I minus 19j, and the constant velocity vector is given to us in the question, which is minus 3I plus 2j, and we need to keep t is equals to 2 seconds over here. So this means that r is equals to 14I minus 6I minus 19j plus 4j. Okay, so we are going to simplify the terms. So r is equals to 8I minus 15j. This is basically the the position of the particle from the origin when t is equals to 2 seconds. Okay, so now we need to find the magnitude of this vector. We need to find the magnitude of 8I minus 15j so that we can tell the distance over here. Okay, so under root of 8 square plus minus 15 whole square. So under root of 64 plus 225. So 64 plus 225, this is 289. So under root of 289, which is supposed to be 17. So 17 meter is basically your answer, the distance as per the requirement when t is equals to 2 seconds. Okay, the r naught vector was not given to you in the question. So we were given the constant velocity vector. Okay, and we were given the position of the particle when t is equals to 6 seconds, which was minus 4I minus 7j meter. Using this information, first we found the r naught vector, the initial position vector of the particle when time t is equals to 0. And now after this, we found the position of the particle when t was equals to 2 seconds, which is 8I minus 15j. And then the magnitude of this vector is 17 meter. This is supposed to be your answer. So this was the question number 2 of the handout, which is June 2010, question number 1. So in this video, I've discussed 2 questions. Inshallah, in my next video, I'll be discussing more questions. So stay tuned to my channel. Thanks for watching.